The only reason I reference this is we're going to graph tangent today. So you better have your mind in the right spot. Put that Chromebook away, sir. Makes me think you're not paying attention. Okay? To know what the values are when you plug them in and then try to put them on an X and a Y axis. So it should be obvious, I know it's zoomed in real quick, that the tangent of 0, when tangent is y over x, I'm pointing to it in class here, y over x, that's 0. So right off the bat, when I go to a graph, I'm going to have a big fat dot at 0, 0 for tangent. I plugged in 0, right? For x, tan of 0, and I got 0 for an output value y. So 0, 0 is a coordinate. All right, and then I did these for you. The tan of 30 degrees. Let's keep it in degrees right now because I think you have a better feel for that. Although when we go to the graph, it's going to be turned into radians. Tan of 30 degrees is root 3 over 3. Gosh dog it. I love that message every time. What's root 3 divided by 3? Go ahead and type that in the calculator. I'd like to know what that is as a decimal. Then in the movie, we can reference why the graph does what it does. Although we definitely go to critical values. 0.5 something, right? So we're at right around a half. And then, of course, tan of 45s is 1. I'm using the unit circle, root 2 divided by root 2, because these are x comma y's, and tangents y over x. Root 2 over 2 divided by root 2 over 2 is 1. Or 1, 1, root 2. Tan of 45 is 1 over 1. This all should be remembered, by the way. Ow! I just hit my elbow. Okay. And then this one is root 3. Type root 3 on your calculator, just get an idea what the decimal is. Just 1.73, isn't it? Something. Okay, so a little bit past 1. So on the grid or graph, the same thing of 60 degrees is pi over 3. You'd have pi over 3 comma 1.7 something. Now it's going to get nuts. Put your calculator in degrees. First of all, do the tan of 90. We should know what we should get for tan of 90, but go ahead and press it. Tan of 90 is 1 over 0. So what'd your calculator spit out? Undies. All right? What does it say is an error? Every calculator is different. Domain error or something? Something like that. Well, let's do this. Let's get nuts with this. Let's go right before 90 degrees and analyze what happens. Take the tan of 89 degrees and press enter. So again, I'm trying to hammer this point down again compared to Tuesday as well. What do we get for tan of 89? 57. What kind of number is that? Kind of what? Big. Well, let's get real nuts. Let's do the tan of 89.99. Press enter. So we're getting closer to 90 degrees. What do we get? 5,000. Do this. Take the tan of 89.999999999. I don't know how many nines you typed, but just do more nines. Get closer to 90 degrees. Does that number go? You don't have your calculator? Someone's not participating. What do we get? It depends how many nines you put. You get like 5 billion, right? What kind of number is that? Extremely what? So the closer I get to 90 degrees, the tan of that angle measure gets what? Insanely what? Large. So what do we have to draw at 90 degrees to identify that behavior? An asymptote. We draw it. It's not there. We draw because we get annoyed by Mr. Samuel saying, hey, let's do this next. Type in the tan of 89.999999999999999999999999999. This is great video stuff. Take the tan of that and then put that on the coordinate on your graph. Whatever. All right. So then what happens when we go here? Let's go negative. This is negative 30 degrees, right? Remember that? Tan of negative 30 degrees is negative 0.5. The tan of negative 45 is negative 1. This is all review. If you don't know this, you are severely behind. That bus is splashing mud in your face as we drive by you. The tan of negative 60 is negative 1.73. Lo and behold, let's be annoying one more time. The tan of negative 90 is undefined. Just real quick, take the tan of negative 89.59, let's say. Tan of negative 89.99999. Press enter. Oh, I just almost put someone to sleep. What'd you get? Is it a billion? It's a big negative number. That's all we need. Okay. So with all that being said, and then of course in these other quadrants we get the similar values. All right, and then we'll analyze that when we actually look at the grid. Negative in quadrant 2, and then positive again in quadrant 3. So here's this graph described what I just said. When we take the tan of 0, we get 0. When we get the tan of pi over 2, which is 90 degrees converted, we get an asymptote because the tan of 89.999 enter is extremely large. But then the tan of pi over 4 we're going to call a critical value. Tan of pi over 4 is comma 1. And guess what? The period has been cut into what again? 1, 2, 3. Someone say that last number. 4. Okay? And then the tan of negative 45 degrees, which is negative pi over 4, gave me negative 1. And then the tan of negative 90, which is negative pi over 2, was undefined. The tan of negative 89 blah was a large negative, which is an improper way to say it, but that's the way I like to say it. A large number with a negative tacked on it. That's a better way of saying it. And then, of course, after this, pi over 2 is the end of quadrant 1. Now this is quadrant 2. And then the next one's quadrant 3. Tan is negative in quadrant 2. Tan is 0. I should actually go here. Negative in quadrant 2. It's 0 at pi. And then it's positive in quadrant 3. This is the 45 in quadrant 3. What I'm trying to identify is this is a cut and paste. So this graph is oh, no, something to notice. You should put this at the top of your notes right now. Note to self. Sine, comma, cosine, comma, secant, comma, cosecant. Period equals 2 pi over b. You already got tested on that yesterday. Here's the difference with tangent and cotangent. Just by the nature of the parent graph, we're going to call this the parent graph, y equals tan of x. The period is the distance between these two asymptotes. That period distance is pi. So now, right below what I just had you write tan, comma, cotan, the periods are pi over b. Because it is. There is no reason other than what we just graphed. And you're going to have that memorized and separated in your brain. Create two separate files with a wall between them. Do not mix those up. So that's how you find a period. And don't worry about the asymptotes, this formula. I don't like formulas. Okay, we'll find where all the asymptotes are when we actually do some questions. All right, so today, and don't worry about this domain little expression. That's going to be something you would never memorize. But we can talk about it as we go through some of these things. Again, don't do this. But the graph is discontinuous. What does that mean? When I try to draw it, do I have to pick up my pencil? Yes or no? Yes, I have to go down here next. So discontinuous. Don't worry about that formula. Don't worry about this. Do understand that the period is pi. That's a huge major difference. Amplitude is only for sine and cosine because you have a high and a low value. That's what amplitude implies. By the way, what is the range of a tangent graph? And the range is covered by one period. What number is way down here for y? Negative infinity. What number is way up here for a number? So what is the range? Negative infinity to infinity. That does go along with not having an amplitude. So always, for a tan and cotan graph, the range is negative infinity to infinity. Now, the domain does have issues because there are asymptotes. Domain means x. I don't think we really talked about that a lot this year. Last year, we did the green book first. Domain, range, hammered in your head over and over again. August, September, October. Then by November, we get into the trig book and we can have discussions about it. So, by the way, What am I demonstrating? That I'm annoying? Sure. But what else am I demonstrating? Symmetry with respect to the origin, which makes it odd, an odd function. I love when I do orange. No, it's odd. Just come up with O words. Okay, is this fun? That's McDonald's. I'm loving it. What's A? It's like a ghost. Boo! Just in time for Halloween. 1. Oh, it's something. That's a ghost number, though. That's why I said it's like Halloween. What's the period? Pi over 2. Okay. Now, I gave those an escape if you have knowledge of Chapter 3. I'm saying that sarcastically because some of us are not there yet. We got to get there. Okay, on any off days, you should make note cards or something and get those tan of 45 is, sine of 30 is. I don't know. All right? But you have an escape because you have to remember one of two things. Well, I didn't tell you about cotan yet. But cotan has a little different thing going on. So what happens with tan? I forget. Mr. S, his voice annoys me. Sometimes I tune it out. So this is what I could do. I could plug in 0 for x. Hey, everybody, what's 0 times 2? 0. What's the tan of 0? I don't remember that, but I remember 0 is here. 1 comma 0, and tan is x over or y over x. So what's y over x? 0. So, that's right. Tan starts at 0 comma 0, unless it's shifted right, left, up, or down. So you have an escape if you don't remember these key components. Oh, okay, wait a minute. All right, so if it's at 0, 0, and the period is pi over 2, the period is this distance. All right? That's the period. That's what period means. So what do I have to do with pi over 2 to get this value? Split in half. Oh my gosh, here's the magic question. What's half of pi over 2? Do you hear your peers? And then, wait a minute. Okay. So I cut the. I don't know if that's right. Is that really an asymptote? What's 2 times pi over 4? Of course, you have to have that ability. What's 2 times pi over 4? What's the tan of pi over 2 if this is the coordinate at pi over 2? Undefined. I'm on to something. And then this is negative pi over 4. I'm sorry. What did I put? Yeah, negative pi over 4. Yeah, right. Okay. I got myself confused, but when I plug in negative pi over 4 times 2, what do you get? What's 2 times negative pi over 4? No time for this. It's negative pi over 2, which is down here. I don't know how you guys are not answering that. You make me angry. What's the tan of negative pi over 2 after you plug this in? Undefined. Okay, and then what's half of pi over 4? Pi over 8. And then this must be negative pi over 8. I'm going to put this over here because I know what's going to happen. Wait a minute. Plug in pi over 8. Oh my gosh. What's 2 times pi over 8? What's the tan of pi over 4, which is a 45? What's the tan of 45? 1. And that is 1 times 1, which is 1. And then the tan of negative 45 is negative 1. Oh, I missed that arrow that was already placed there. And then it ain't no thing, chicken wings, that we do another period. Because look, 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 4 pi over 8, 4 pi over 8, 4 pi over 8, 5 pi over 8, 6 pi over 8, okay, 5 pi over 8, comma, I love this game, 1. This is already there. 3 pi over 8, comma. Okay, and then, I don't know. I hope you get the idea of why we're doing these arrows forever. In this case, when I get close to pi over 4 here, which is 45 degrees, right? But 2 times 45 is 90. So when I plug in 44 degrees, I know it's radians. I just don't want to think of the decimal right now. My head hurts. 2 times 44 is 88. Tan of 88 is a large number. All right, so that's why the numbers start taking off when you get closer and closer. That's the idea of an asymptote. It's behavior of the graph. All right, and then I'm not going to bore you with cotan. I guess a little bit. I'll go back up to this real quick and zoom it down and just talk about where the asymptotes are located. It should be very simple. What's the cotan of 0 degrees? All right, well, that's x over y. So what's cotan of 0? Undefined. What do we have right away at 0? An asymptote. Cotan's so easy. And then look at the cotan of 180, which is the same thing as pi. What do you get for that? An asymptote. What do you get for the cotan of 90? X over y. 1. So the cotan graph is complete from 0 to pi. 0 to pi. Or 0. Did I say 1? I'm sorry. I meant 0. You're right. And then the 45s, the cotan of 45 is still 1, just like the tan is. And the cotan of 135 is negative 1. So we can talk about that when we look at the actual parent graph of cotan. It's very simple. And here it is. Cotan is a lot easier than tan. Actually, they're both easy. If you have any knowledge of chapter 3, you can always have an escape. You can always find out the difference between the two. If you just know the tan of 0 is 0 and the cotan of 0 is undefined. They start differently. And actually, they look different. Okay, so we just said that base stuff. And I have the graphs here. Look at, if you ever, you wanted to get an escape, wait, what does cotan and tan look like? That's what you draw real quick. Because these are the key critical components. 1, 0 at 0 degrees or 0 radians, 0, 1 at pi over 2, negative 1, 0 at pi, and then at 3 pi over 2, you should put 0, comma, negative 1. Then you'll know where the asymptotes are, if you just have the basic knowledge from chapter 3. There should never be a problem. There really shouldn't if you put everything together. Oh, crap. Sorry for the language. I just looked at asymptotes over here, and I forgot to do asymptotes. Could you switch gears with me for a second? Well, you know what? You have to. Hey, what kind of line are these asymptotes? Don't say dotted. Don't you dare say straight, because all lines are straight. That's like saying, hey, there's a female girl walking down the hall. No, what kind of line is this? Don't say purple. Vertical. So here's the equation of the asymptotes. Bull honkies. I'm not doing any of that. It's x equals a number because that's the equation of a vertical line. And where's this one located? What's that number right there? So you pick one. Pick any one of them. I could have put negative pi over 4 here. Just pick a starting point. Now my next question is how far is each asymptote away? In general, they are the what away? The period. What is the period? So what do you do about it? Pi halves what? K or what other letter? I don't care. N. It's usually K or N, not X. I try to stay away from X. And all K is an integer. I plug in 0 for K, I get pi over 4. That's the first one I wrote down. I plug in 1 for K, I get 3 pi over 4. Because that's the next one to the right. I plug in negative 1 for K, I get this negative pi over 4 asymptote. So that's why we do this generation of that stuff. My bad, dogs. Switching gears on you there. Because I saw asymptotes there and I realized I didn't do it for the other one. Hey, but that's why cotan's great. Whatever the period is, the first asymptote's at 0. The next asymptote is the period. Very simple. And then what do you do to the period? You cut it into what? Fourths again. But in this case, the cotan of pi over 4 is 1. The cotan of pi over 2 is 0. And the cotan of 3 pi over 4 is negative 1. So this graph decreases as you read left to right. Right? You see it? Whereas tangent goes up or increases when we read left to right. So these are the little differences if you want to memorize. But again, you always have an out if you have just the basic knowledge of chapter 3 to evaluate these numbers. So, and it is smart to do that because that stuff is coming back. We ain't doing this. Nope. The period is pi, of course. And then, what kind of symmetry is that? Or Origin, I mean. And then what does that make the function? Odd. Okay, I'm going to take a break. I'm about to faint. All right, we just took care of something important there. Sorry for the break. All right. Okay, what's the amplitude? There isn't one. That's a trick question. What's A, though? 1/2. I did that on purpose, kind of. What's the period? Oh, how boring. Pi over 2. Same thing. Okay, now, Mr. S, I can't stand his voice. Sometimes I don't listen, so I forgot. All right, so let me plug in 0 real quick. What's 0 times 2? 0. What's the cotan of 0? I don't remember. So I do this. X over Y. Undefined. That's right. Mr. S, I kind of tuned him in a little bit. Cotan starts with an asymptote right at the y-axis. Oh, if that's the case, then the period's pi over 2. What should be at pi over 2? Maybe. I'm going to save myself, though. When I plug in pi over 2, of course you have to be able to do this math, which angers me. What's pi over 2 times 2? Pi. Got one person. And then this is pi's number. And it's x over y, which is what? Undefined. So I'm good. I feel really good about myself. Now, what's this number? Half of pi over 2. Pi over 4. I'll check that one real quick. I'll check them all to be annoying. What's half of pi over 4? Not be annoying, to teach. You know, it's not about, okay, this is the formula, how I graph. I just have to have this memorized. There's always an escape. 1 pi over 8, 2 pi over 8. Ooh, much better than the other hour. 3 pi over 8. And actually, I got to reverse that. I screamed in here, didn't I? Oh, I'm sorry. I actually threatened them last hour. That was to tackle them like an NFL linebacker if they did not answer the last question, if they try to get out the door and that bell rings. I did. I didn't tackle him, though. All right. Now, pi over 4. What's 2 times pi over 4? Well, okay, I don't remember the tan of pi over 2, but I could always do this. Or cotan. What's x over fumble y? What's x over y? 0. Everything's falling into place. Pi over 8. What's 2 times pi over 8? Pi over 4 is a 45. What's always a cotan of a 45? 1, but it's 1 times a half. So it's a half, right? That's how that works mathematically, why that turns into a half. And then, not to bore you anymore, too late. 3 pi over 4 happens when you plug in 3 pi over 8. 3 pi over 8 times 2 is 3 pi over 4. That's the 45 in quadrant 2, which is -1 times a half. So you always have an escape. Now, we're not going to bore you with plugging in cotan of close to 90 degrees in this case. It would end up being an infinitely negative large number. Okay, then very easy. You just, if I had to do 2 periods, then you just negatize it. If I can make up a word. And then we're going to do the asymptotes, which are really easy. -3 pi over 8. And then it's all about these critical values you got to write. Do the dots so I could see the connection of those. Before I answer any questions, ooh, look at these. I forgot to do that the other hour because of time. But what are the asymptotes? Well, very easy. Where's the first one? And it's x equals because they're vertical. 0. Then how far away are all the rest of them? Pi over 2, what? K, N, don't care. Pick one of the two. That's usually what books choose. And then, ooh, what the heck does that mean? What's f of pi over 8? What's the answer? How can he said a half immediately? Because a graph is a series of inputs and outputs. When I input pi over 8, what do I get as an output? 1/2. That's what this question means. I love those questions. What's f of -3 pi over 8 now that I've said this? 1/2. What's f of 3 pi over 8? -1/2. The graph is a series of inputs and outputs, a series of coordinates. Okay, so remember that too. I just like throwing that stuff in. Okay, cotan. What's A again? I don't know why. 1/2. What's the period? It's pi over 4. Again, I'm going to be slightly annoying. I used N here. slightly annoying, by, oh, I forgot. So I plug in 0. 0 times 4 is still 0. The cotan of 0. All right, I need this again because I forget everything. 1 comma 0. Cotan is x over y. Undefined. So that means my asymptote should end here at pi over 4. I don't trust that. What's pi over 4 times 4, everybody? Pi. One girl said it. What's the cotan of pi? When I throw in pi over 4, I get pi. What's the cotan of pi? Undefined. I'm good. What's half of pi over 4? Pi over 8. What's half of pi over 8? Pi over 16. 2 pi over 16. 3 pi over 16. I know where this is going, so I'm going to put this up here, and you'll get there. And then bore you one more time. Pi over 16 times 4. Pi over 4. 4 over 16 is all the math we got to do, folks. Fractions. Ah! What's the tan of 45 degrees? 1 times a half, though, is a half. Okay, done doing that. I'm also doing it because at least at some point, by osmosis, anyone know what osmosis is? Just eventually it's going to just infiltrate your brain, even if you're trying to avoid it. Me constantly talking about these fractions, all 28 of us will eventually figure out how to do it. And if not, I'm doing this for a whole year all the way to May, there's something going on. So I did say, I yelled at you, it's not my job to teach you 4th grade math, but I teach it every stinking, anyone? Day. Until everyone's on the bus. I don't want people getting mud in their face as all of us are looking out the window at you, driving by. I want you to be on the bus. Okay, then where are the asymptotes? Very simple. X equals 0. Do I really need the 0? Plus, how far away are they? Pi over 4, and then I used n this time because I don't care. And then what n is an element of the integers. So n is an integer. And what is an integer? It's a number. That's right. It's not a fraction, not a decimal, positives and negatives. 0, 1, -1, 2, -2, so on and so on and so forth. When I plug those numbers in, I get all of these asymptotes and the ones in the future and in the past. Last one for fun. What's the amplitude? There isn't one. It's a trick question, but what's A? 3. What's the period? Ooh, interesting. Pi over a half is what? 2 pi, fraction people. Hey, oh, I forget. This is so mind-numbing. So let me just plug in 0 real quick, and then I'll at least know how it's done. So at least you should get to this point. Is it an asymptote at the y-axis, or is it 0 at the y-axis? Very simple. Plug in 0. What's 0 times a half? 0. What's tan of 0? I forget again. I have the memory of a housefly. So I'll do this real quick. Tangent is y over x. Y over x. What's tan of 0? 0. Oh, tan starts at 0, 0. So then what I have to do is put what here? And put what here? And what's this distance from here to here? This distance is 2 pi. So what's this number right here? Half of 2 pi. And I could check that very easily. I plug in pi times a half, I get a half pi. Half pi is up here. The tangent of that is undies. So yes, that should be an asymptote when I plug in pi. And then half of pi is, come on. Half of pi is, come on. All right, and then, okay, I forget this as well. When I take half of pi over 2, that's pi over 4. That's that 45 in quadrant 1. What's tan of that? 1. But then 1 times 3 is 3. So actually it's stretched. And then the negative one's here. So it's stretched. Kind of try to show that, but it is tough. 1 pi over 2, 2 pi over 2, 3 pi over, what am I doing? Another what? 4 pi over 2, no time. 5 pi over 2, 6 pi over 2. What do I have at 3 pi? 2 pi comma, careful. 2 pi comma, 0 actually. 5 pi over 2 comma, 3. 3 pi over 2 comma. Okay, I'm going fast because at this point this is redundant. But I'm just giving you an extra example to get you to figure this out. Asymptotes are located at x equals, pick one. Pi actually. Plus, how far away are they? 2 pi. Pick a letter. I heard n first. Sorry, you lose.